Okay, boys and girls. Got some notes here. He'll retain it all in his brain. Okay, so make sure that you have your calculator out and turn to the very back page of your notes. We're going to leave the world of polynomials, and we're going to get to the world of exponentials and logarithms. Today's lesson should go pretty quickly and easily, but instead of looking at y equals x squared, we're going to look at functions like y equals 2 to the x. And these have a very specific shape to them. And to discover that shape, I'm going to look at my calculator. If you'd like to turn yours on, you sure can as well. And as I plug this in, y is equal to x, and I'm going to go to my table, and I'm going to start with 0. What is 2 to the 0 power? What is anything to the 0 power? 1. So you see, if you plug in 0, you get 1. And then if you take 2 to the 1, you get 2. If you take 2 squared, you get 2 to the 3rd, 2 to the 4th. So you can see that these values are actually going to get pretty large pretty quickly. 2 to the 10th gives you 1,024. So as you move to the right, the y values go up very quickly. Watch what happens as we move to the left. Go up here, get rid of some of these values, and punch in some new ones. Again, 0 gives me 1. Any idea what negative 1 will give me? 2 to the negative 1. What does that mean? It means 1 over 2, right? Negative means you flip it, move it to the denominator. So you can see you get 1 over 2 or 1/2. Whereas negative 2 would be 1 over 2 squared. To the negative 3 would be 1 over 2 to the 3rd, or 1/8. So look at these values. They get remarkably small. In fact, if you plug in, say, negative 8, you can see that you get a value very close to what? 0. It's very close to 0. But it doesn't matter what kind of number you plug in, you won't ever get below 0. And so that gives us the shape of the graph. Anything to the 0 power is 1, so we know it goes through it has a y-intercept of positive 1. And as we plug in negative values, we come out with values very close to 0 or very close to the x-axis. And as we move to the right, the values get very large. Now, this graph never actually crosses the x-axis, and so it has a very special line that we call. It's called an asymptote. Some people pronounce it asymptote. Some people pronounce it asymptote. It doesn't matter. Dictionary and other sources allow you to put the emphasis in either place. So I say asymptote. Doesn't have a P right there. And it's an imaginary line that the graph approaches but never touches. In this case, the line is y is equal to 0. So that's the parent function graph of what we're looking at. Okay. Now the question is, what if, this is for base values greater than 1, so like we had 2 to the x. What if we choose a value between 0 and 1, say 1/2? Y equals 1 over 2 to the x. How will the graph be different? Well, how is the number 1/2 related to the number 2? It's 2 to the what power? Negative 1. Would you agree that 1/2 to the x is the same as 2 to the negative x? Can you convince yourself that those are the same? If you apply the negative to the 2, you would get the 1/2. So if this is the graph of y equals 2x, if this is the graph of y equals 2 to the x, what happens if we put a negative in front of the x? Do you remember? kind of reflection is it? Horizontal over the y-axis. So this graph will, again, go through 1 because anything to the 0 power is 1. But instead of starting down and finishing up, it will start up and it'll tail off this way. If you just think about it for a second, 1/2 to the 100th power, is that going to be a big number or a small number? Small number. 1/2 times 1/2 times 1/2 is going to get very, very small. So that's the graph that we get. Okay. Have you seen this letter E before? E is an important number that pops up in nature quite often. It represents kind of a rate at which things grow continuously in nature. For example, my daughter Tenley, she just turned 4, so we measure her height. Every few months we measure our kid's height. We have a board at home that we mark the heights on and we write the date and stuff. Okay. Does she grow just every 6 months or does she grow continuously? Continuously. Your money in the bank, does that grow, say, once a year, or does that grow every day? Okay, it could be every week, it could be every day, it could be every year, but generally speaking, they don't have continuous rates, okay, for finances and things like that. So when things grow continuously, there's a very special number that comes up. And it has a base value of 2.718. It's kind of a number like pi. It's between 2 and 3. It's about 2.72. So this graph, y equals e to the x, is going to look more like the first graph or the second graph? The first graph, because its value is greater than 1. So this graph of y equals e to the x, it'll pass through 1. It'll start down, and it'll go right up through there, just like that. And it does have this horizontal asymptote. I forgot to draw it on the last one. The last one is that horizontal asymptote as well. What do you think happens with y equals e to the negative x? Yep, looks like the second. So these are your parent functions. And when we draw them, we should always draw an asymptote, and we should draw a point that it passes through. And that'll be enough information to discover things that we need to know about the graph. Do notes help you follow along in class? Okay. I never got notes when I was in high school or college. And when I started teaching, I noticed my students weren't following along. They weren't performing well. So I started giving them the same stuff I was doing on the board, and I found it was helpful. From that point, I tried to adjust things. This is the summary of your notes that you will have over the course of the unit. So as we move forward, a lot of times I'll give you one page that kind of summarizes everything. Especially in trig, you'll have a lot of those. So you could turn back to this anytime you need some of the information you want. We now turn to the front and we start some of the examples for exponential functions. It says sketch a graph of the following functions. Y equals 4 to the x. Okay, is 4 greater than 1 or less than 1? So it's going to have this kind of a shape. And what point does it cross through on the y-axis? 1. And what is the asymptote? Y equals 0. How about 1/4 to the x? How will that look different? Yep, horizontal reflection. Again, it will pass through 1, start up, and it will finish down. Again, it will follow the asymptote, y is equal to 0. Any questions how I come up with those two graphs? Okay, which part? If the base a is greater than 1, it will generally have that shape. If the base 1/4 is between 0 and 1, then it will have that shape. Y equals 2 to the x. Is it going to look like the first graph or the second graph? First graph. And when we draw the graph, we generally don't show any difference in shape between them, even though one is a 2 and one is a 4. Obviously, the 4 will get larger more quickly. However, it's really not that important as we draw the graph, okay? Unless you're trying to compare them. So let's get to the more interesting graphs. D. How does D differ from the others? what does a negative on the front of the function do to it? Flips it over the x-axis. It is a vertical flip. So instead of passing through the point 0, 1, it will pass through the point 0, negative 1 because it flips over the x-axis. If you flip the asymptote, since it's on the x-axis, it will stay where it is. And as we flip this shape, it will start close to 0. Instead of tailing off going up, it will tail off going down. How's that? How about the next one, y equals 3 to the x minus 4? How does the minus 4 affect the graph? It down 4. So instead of passing through the point 1, it will pass through the point 0, negative 3. So 1, 2, 3. So I go down 3. Instead of the asymptote being at y equals 0, the asymptote will be at y equals negative 4. Shifts down 4 units. F. 2/3. How's that going to change things? Yeah. 3 just happens to match up with that. The reason why I cross at negative 3 is it would cross at 1, but we move 4 units down from 1 to get to negative 3. Has nothing to do with the 3. 2/3. Is that going to start down and finish up or start up and finish down? It wants to start up and finish down, and it would pass through the point 0, 1. However, look at the type of shifts that we have. What does this plus 1 make it do? Go up 1. What does the x minus 2 make it do? To the right 2 units. So instead of passing through 0, 1, we go 2 to the right and up 1. What is 2 to the right and up 1? 2, 2. If I go 2 units to the right and up 1, I will get to the point 2, 2. The asymptote, it was at y equals 0. Now it will be at y equals 1. Because it's plus 1, so it shifts everything up 1. And you told me it started up and then finished down. Again, I didn't draw where it crossed through the x-axis this time. I simply gave, or y-axis, I simply gave a different coordinate. We can figure that out, but it's not that big of a deal right now. Okay, before you flip it over, we want to look at another piece to these, and that is the domain and range. As you drag a vertical line across, are there any numbers that you can't plug in here? No. So the domain for all of these will be all real numbers, but the range does change. As I take a horizontal line, whoop, oh, don't do that. There we go. Okay, I'm not going to drag it because I don't want to mess up the graph. As we drag a horizontal line up, do we get any values down here? No, we don't get values until we get greater than. So the range is y is greater than 0. Could it be equal to 0? No. Letter B, what's the range? Still the same thing. Y is greater than 0. You can't have any negative numbers. You can only have positive. Yes. Right. C. Same thing. Y greater than 0. Domain will always be all real numbers. For exponentials, for logarithms, that will be different. D. What's our range here? Y is less than 0. Your range always requires your knowledge of the asymptote. If you look at the asymptote, that will give you a hint. Your range for this one y greater than -4. And your last one, y is greater than 1. Yep, good. Okay, flip it over. Find the exponential function that passes through the following points. An exponential function has the equation y equals a to the x. So here's an example. Y equals 10 to the x is an example of an exponential function. We want to know what value a should be. For example, you're used to doing y equals mx plus b, and you end up with, say, y equals 2x plus 3. So you found 2 and you found 3, and you wrote your equation. Now what we're going to do is we're going to find a and write our equation. So what do you notice about all these functions? They all pass through what point? Is that surprising? But they all pass through a different point after that. We're going to use that. X is my 2, or 2 is my x value, and 25 is my y value. So if I write y equals a to the x, I don't know the a value, but I do know the x and the y value. The y value is 25, and the x value is 2. So this reads, what number do you square to get 25? 5. So since a is 5, my function is y equals 5 to the x. That is the function that passes through, that is a function that passes through those 2 points. Yes. No. You are right. No, your question about a negative really requires some of our knowledge about logarithms to answer that. Okay? -5 is not a valid input for a. We don't put in negative numbers. And once you see logarithms, you'll understand why. Anything to the 0 power is 1. Yeah, because -5 to the 0 power is still 1. Okay, this one. All right, let's do C first, okay? Y equals a to the x. Y is what value? Question. It's not, it's not -8 to the x. It's 8 to the x times -1. See the difference? 8 equals a to the third. What number do you cube to get 8? 2. So therefore your function is y equals 2 to the x. Yep. Some of this will be reviewed from last year, and so I'll go more quickly through the stuff you saw last year, and I'll spend more time on some of the new stuff, which will be really Tuesday and Wednesday. B. This is x, this is y. A little trickier here, folks. I have 2/3 is equal to a to the -1. What number do you take to the -1 power to get 2/3? 3/2. Taking something to the -1 means you take the reciprocal. So what number did we take the reciprocal of to get 2/3? We took 3/2. And finally, this is x, and this is y. And what we have is 1 over 10,000 is equal to a to the 4th. What number do you take to the 4th to get 10,000? 10. So what number would you take to the 4th power to get 1/10,000th? 1 over 10. So y is equal to 1/10 to the x power. Notice that all of our answers have a y and an x in it, as they should. Some people put other numbers in that place. Can somebody give me, instead of writing 1/10 to the x, what would be another equation I could write that would be exactly the same? Yes. What else? Thank you. 10 to the negative x. Those are the same. All right? Before I give you your assignment, I ask you one final question. Why is anything to the 0 power 1? What is x to the 5th over x to the 3rd? Very good. So let's use that same type of thinking. What is x to the 7th over x to the 7th? Or if you do what you did here, or if you did what you did here, you would subtract, you get x to the 0, correct? Anything to the 0 is 1. Here's your assignment. Some of the problems are matching. Folks, do not put this homework off. I'm telling you that last year did not go well with the logarithms test. And so I need you to stay on top of your game and get ready for your test on Friday next week.